Today you have me, Kennedy Murray, and Logan Preble. We will be doing example problem 5A1. What we are initially given is a crate of mass m slides to the right on a rough surface with a kinetic coefficient of friction of mu k. You can see those given here in the list of givens. You can see the schematic with some basic dimensions. This is a no-slip surface, so you will have a coefficient of friction and a friction force. The first step of what we're going to do is look at a free body diagram already drawn here. Now we know that the weight force comes from the mass center of gravity, which is noted up here as G. The other forces are the reaction forces at the 2 points on the bottom, which is what we are asked to find, which includes two vertical forces, normal A and normal B, and two forces pointing to the left, friction of A and friction of B. The first step of what we're going to do is the kinetic equations, which simplify out to the sum of the forces in the x direction equals 0. Now these forces are simply going to be F of A and F of B. This will look like equals minus FA minus FB all equal to, see here, mass times acceleration in the x direction from G. This will count as your first scalar equation. Next step is to do the same thing in the y direction. So my f's in the y equals to 0, which gives you normal A plus normal B is minus the weight force, mg, is equal to 0, because we know that the crate moves to the right, so there is no vertical acceleration. This is your second scalar equation.
Gotcha. So then next you have to find your moment about the mass center of gravity, which is noted as point G, as seen up there in the diagram. And for this, as for this, we are going to be proving that the moment about the mass center of gravity G is going to be equal to 0. And we're going to show this by showing that
No, that'll be fine.
Okay, gotcha. We can do it. Yeah, for sure.
What we have is the normal forces of normal A times the horizontal distance, which is B, minus the normal of B times the horizontal distance, which is also B again, minus the friction of B times this distance D, as well as minusing the friction of A, also times the distance D of D, all equals 0, which gives you your third scalar equation. Now we have 5 unknowns and we only have 3 scalar equations right now. What we're looking for is your friction forces, your normal forces, and what's left? AX, and your acceleration.
So the equations, you can then break these into using your 3 knowns, solve for your 2 unknowns are going to be, you can see this, yeah, once my head gets out of the way. It's going to be F of A is going to equal to the coefficient of kinetic friction times your normal force A. And this will be your fourth equation. And then you're going to have F of B is going to be equal to the same coefficient of kinetic friction times your normal force B.
Which gives you your last and final scalar equation. From here, you can take these variables, plug into your given equations up here, and solve for your two forces on each side. Good luck.
Is that the screen?
I always forget.